So my name is Bruno Bowden. I used to work at Google for many years, but left several years ago. One of the things that I worked on while I was there was leading the engineering team on Google Earth. And we had a very big challenge in that in running across a lot of different platforms. We ran on Windows, Linux, Mac, across many different OS versions, and also iOS and Android as well. And doing a common build and sharing code was absolutely essential in making it possible to work across so many different devices. And in one of the things that came out of that as part of learning about engineering was something about code smells. And I hate to be talking about smells amongst a developer audience, but it's a very important issue. And on the Wikipedia page, the #1 example that they list of this is duplicated code. And it's something that we've all done, and we don't like to talk about that much, but it is part of your life as a developer. Now, I was thinking earlier, actually, about, that I think there might actually be the one acceptable place where you actually write out code that you've already written before. And I was going to ask people here about, had they any idea about where that would be? It's a really interesting question. And I thought, sorry. In tests, I think that's actually a very good answer. I think the one I would offer myself, I think is similar, is in technical interviews. When somebody asks you to implement a linked list, you should know how to do that cold, and you just write it on the board as if you're writing it from memory. But when you're doing production code, when you have duplication, what that means is that you've got things that you need to debug twice. You've got things that you fix in one place and then forget to fix in the other. And just generally, you have greater complexity. And probably the biggest thing that I've learned from a great deal of pain over the years is that part of being a successful developer is a fight against complexity. Because as you make a system simpler, it becomes easier to manage, it becomes more robust and reliable. And this is partly what this talk is about. So partly on doing better, there was this project out of Google several years ago. This great engineer there, used to work there, called Bruno Bowden, had this idea about, could we actually run Java on iOS? And the idea was that he would actually take Java code and then convert it or transpile it into Objective-C, and re-implement the Java runtime environment, support all your basic libraries, and do it in a way that's compatible with the Apple terms of service. Now, the correct response, if somebody inside of your company suggests a project like that, is this. I think that the even more appropriate response is a bigger question. And there was actually a great deal of skepticism even inside of Google about whether this was possible. But there are cases in which this is actually very relevant. So for example, if you're running, say, something like a spreadsheet app where you want it to be compatible across different devices and on the server, there are essentially two ways to do that. One is that you exclusively hold the code on the server, which means that everyone gets consistent results. Or you try and re-implement that code on different platforms. And when you re-implement code on different platforms, you might get, and you get it wrong, you get an inconsistency in your spreadsheet output. And that is just intolerable for a spreadsheet application, as it's intolerable for many other products as well. And so Google already done a project called GWT, Google Web Toolkit, which allowed you to convert Java into JavaScript. But this idea of converting it into Objective-C was considered a lot more challenging. But ultimately, they were successful, and the project, they actually advertised this by the team as being bug-for-bug compatible. That if you have a bug in Java, in your Java code, we're going to give you the same bug in Objective-C, which I think is a fantastic standard, but that indicates the sort of like the level of maturity and sophistication of the technology. The performance of it is very good, and they specifically avoid doing anything in the UI layer. And so this is for business logic, networking, caching, basically as much as almost as much as possible that you trying to share as much as possible except for the UI. The example of this was actually the Inbox app. It's a fantastic app. I love what they've done with it. And the way that they did this was to use J2Objc, which stands for Java to Objective-C, for sharing the code on iOS, then GWT for sharing it through the web, and sharing 70% of their code base, which is extremely impressive. So there are a number of limitations about it, though. The main one centers around memory management. So what it does is reference counting instead of garbage collection. And so this is basically similar to what iOS does in automatic reference counting. And you might think, well, how on earth can you have confidence that your app will remain stable and not leak memory over long periods of time? And so they have this amazing system that goes along with it called Cycle Finder, which transitively looks at all of the dependencies between all the classes in your application, and then proves that you cannot create any cycles within it. And this is difficult to set up, but in the case of Google, they've actually done it successfully for Gmail, and they've done it for other applications as well. The other limitation about it is that you have to have the Java source code. It doesn't yet work with bytecode, for example. And there are some limitations on security support. So it primarily just makes available what's available in NS URL session. So here's an example of this. You've got a simple Java class, and you can translate it, and we haven't got any errors yet. And this is the output that it will give you. And what you can see is how the sort of like package name, the method name, and the method types, or the parameter types, have all been concatenated into this fairly long string. But it looks like it might be something happening there. So you then compile it, package it, and then run it, and you get an output from it. And it does actually work. So that project is open source from Google. It has been for some time. And where I got involved about a year and a bit ago was about making it more accessible by essentially developing a Gradle plugin around it. I was working with a friend, Advay, another great engineer, and the plugin that we've developed is really designed to work well with Android Studio and Xcode, designed to be fairly efficient and easy to use. So the starting point for this is that you've got your existing build.gradle file for an Android application. Now, the challenge with this, though, is that, of course, iOS doesn't support everything that exists within Android. And so what you have to do, and this is probably the most challenging bit, is basically separate out a project which is Java-only code. Okay? So you have one project which is your Android user interface and anything that uses Android APIs, and then put your business logic, caching, networking, as much stuff as possible in this shared project. And you can start off with this shared project being very, very small, and then grow it over time. Or where I tend to find this works best is if you're starting a project from scratch and you just enforce the engineering discipline from the very beginning of putting as much code as possible in the shared project. Now, once you've done that, in the shared project, you've got your straightforward Java plugin, you've got a few dependencies, and this is really where you have to pay attention because there's going to be a lot of code coming up. So to start using this is what you do. If you only ever remember one line from this talk, that's your starting point. Now, I believe very strongly that in order for a tool to be good for developers to use, it has to be as straightforward as possible. And so the way that the plugin is developed is that, the way the plugin is designed is that you start with that one line of code, and then it gives you very constructive feedback about what you need to do next. So the idea is you put that in, and then based on the feedback or failed build warnings, it will explain to you about the additional setup that you need to do without having to go and look at the documentation. So the main thing that it will tell you is this is what you also need to add into the build.gradle file. The auto-configure deps was, this is probably one of the most impressive parts of it, is that since it has to actually use source code rather than class files, for many Java libraries, they actually publish source jars alongside the compiled jars. And so what it will actually do is that it will look through your dependencies, go out and find the source jars if they exist, download them, translate them, recreate the dependency chain within Objective-C, and then compile it all together. And surprisingly, it actually works. It's not foolproof by any means, and it would be much, much easier and more reliable, once it can handle class files. But that's something that we're experimenting, with at the moment. Then you point it towards your Xcode build and say, where's the folder? What are the names of the targets? And then the final configure is basically just working around a Gradle limitation. And, but it's the only one we had to work around hands. Other than that, it's been a real pleasure working with the team. And they've given me a lot of assistance, and I still haven't had to buy them a beer yet. So I'm very grateful for that. So this is, you don't need to go into all of this detail, but the point is that you have an Android project, the shared project, which has as much code as possible, and then inside iOS, the Android and iOS projects both depend on that shared one. The way it integrates with Xcode is using CocoaPods. CocoaPods, for those of you who are not as familiar with it, is a way of managing dependencies within Xcode. Very popular and widely used. And the idea is that you only need those couple of lines, and then it figures out everything else for you. And so it will include the header files. It will link in both the J2Objc runtime, any of the dependent libraries, and you shouldn't need to muck with it that much. We shouldn't need to muck with it at all. The only thing you need to do manually is add stuff to the bridging header. Bridging header is primarily important for, or is used for when Swift code is accessing Objective-C. And so the long and the short of this is that it was essentially a really, really complicated way of me avoiding having to write any Objective-C at all. And that the only code that I need to write on the iOS side is just Swift, and the headers come in, it auto-completes, you can do debugging and so forth, and it works really well. Other such things, designed to have helpful error messages. So we looked at quite a number of the error cases that people encounter using it, and instead of having cryptic messages, it will actually try and explain that, what caused it, and therefore how you might be able to work around it. Now, of course, if you actually have if you're using Mockito Spy, Stepan will be having words with you afterwards. But other than that, I love Mockito. So some of the caveats about using this are that you have to separate out this Java-only project. But what's good about that is that you then have a project that can very, very easily move around between client and server, for example. Because the UI has been separated out, it both enforces greater discipline on organizing your code and generally makes it more testable as well. The plugin is also alpha state at the moment, but I'd emphasize that the quality is actually pretty high on it already. Lots of unit tests, continuous build across several different platforms. So we run on Linux, Oracle JDK, OpenGDK, Mac OS X, and we even had one guy talk to us about it. He's saying he wanted to translate code on Windows, even though you can't build it. And so we've made it work. And so it means that if you have a Windows developer, they can actually run part of the system and have greater confidence that they're not going to break other people working on other platforms. You could do with some more integration tests with like the end-to-end experience, but generally it's pretty good. Future plans, we need to do some more work for bitcode support so that it can run on watchOS. And the other thing I was interested in is about feedback on people using it, and heading towards a beta release is going to be early on next year. And so that we feel like that this is actually mature enough now that it can be more widely used. What I would emphasize, though, is it's not for the faint of heart, and it's something that it really benefits from actually from a team where you can actually force a good engineering discipline about how you build these projects. The other thing I wanted to briefly mention is something I've also been looking into is RoboVM. This is a similar system designed for sharing code across platforms. What it does is it takes bytecode and then runs it through LLVM, and the LLVM stands for low-level virtual machine, where it basically reuses Apple's open source compiler in a way that optimizes it towards each architecture. And also it can work with Java 8, Kotlin, Clojure, and so forth. Anyway, there's a bunch of detail there, but the main point is this though, and here's all the links for you to follow up on this, including my content information. But the main point is that that there is a huge benefit of having shared code across platforms. It means that not only do you actually have a more efficient development process, but when you come to do releases, you're guaranteed that your product will be finalizing at the same time, as opposed to one platform dragging behind because the implementation hasn't caught up with the other. And this is an area that I'm deeply interested in, and that I'm looking at both how we can actually make that a better experience, supporting, at the very least, supporting the JVM on iOS, and secondly, is also looking at the Kotlin language as well. And like the talk earlier from Ty and Johan, is that I think that Kotlin actually has a very good trajectory for it. And since it's coming up to finalizing the beta and 1.0 release, I think that holds a lot of promise in the future as well as a cross-platform language. And so that's, I've got just briefly down here. Now, wait, there we go. I know, it's, I love my wife. So this is an example of just a build that I did, and I won't rerun the build because it'll take 15 minutes, and I don't think you can last that long, or I won't impose on you that much. But what it's doing here is that where it works really well is that it integrates with the existing Java, the existing Gradle tasks that are created by the Java plugin. So what it will do is that it runs through the Java test, compile, and build process, and only after that is working will it then actually essentially reuse the same inputs in terms of source files, dependencies, and so forth to basically recreate the build in Objective-C as well. And this line here, it's downloading the source jar, and this is an example where it's actually using the JSON and further below Guava, compiling it to all the different architectures, and then running all of the unit tests as well, and then finally finishing on the build. And this is actually, again, something worth emphasizing is that it will automatically take all of the unit tests in Java and then automatically run the Objective-C versions as well. And so as long as you've got good unit test coverage, you can be pretty confident that as long as you've got pretty good unit test coverage and they all pass on both platforms, then you can be very confident that it will work well. So that's most of what I wanted to share. Happy to answer questions, and thanks for listening. Yeah.
Hi, a quick question about the dependencies in the project. So,
Yeah.
I mean, it's well-known fact that like a lot of the projects use like open source projects that are in Java, like they use them as a dependency,
Yeah.
right? So how about that? So, like we don't have source code for that, and so how would we go on to resolving those kind of dependencies?
So for many of the open source projects, some publish source jars and some don't, where we're already doing stuff like Yoda convert, some of the Apache commons, Guava, JSON. There's a bunch of stuff that we already support quite happily. For a library where a source jar doesn't exist, it isn't possible to run this on iOS using J2Objc. It can be done with RoboVM, and which accepts bytecode, and they're looking in the J2Objc project about also supporting bytecode and class files in the future as well. But it's not something that works right now. Yeah.
I see. All right. Thank you.
Since Apple open sourced Swift, can we go backwards and share Swift code between two platforms, for instance?
Yeah. Okay, so you're talking about, since Swift being open source, about sharing code on both platforms. First off, I think Swift is a fantastic language. I think that they've done a lot of innovation, and I think that actually it's something that's reflected in Gradle as well, that it works, I think, really well to have an open source project where you actually have a strong company pushing it. Apple's doing that with Swift, Gradle's doing that with Gradle. And you're not doing anything else, are you, Hans? No. Yeah. So what I've done for my own personal projects is that the shared code is translated to Objective-C, then I add all of the header files in the bridging header, and then I only program in Swift. On the iOS specific code, I only program in Swift, and then I just call into the shared library as I need. What I don't know, and I have no idea if it will ever happen, is, for example, that you could take a Swift app and then run it on Android. I think that that's fairly unlikely, given the complexity of the sort of like supporting all of the APIs. Whereas, for example, what J2Objc has done in terms of the Java runtime environment, you have a very well-defined set of APIs, and they've gone through a tremendous amount of work to basically proxy a lot of the internal APIs of iOS to make it work. Yeah.
So what does Apple have to say about all this?
Ah, right. So it's talking about Apple, to what Apple has to say. Yes.
The most important person on your technical staff is your attorney.
So that given that even though I don't work at Google, just to make that clear, the J2Objc project is run by Google, and even though they develop it as open source. And so what it's doing is that since it's generating source code, it means that you could take that source code, import it into Xcode, and you would absolutely be following all of the Apple terms of service. And it's very hard to say that it's essentially about the Apple terms of service is that they've gradually grown more relaxed over the years. And I think that since Swift has caught on and got so much traction, I think that as long as Swift is popular and as it well deserves to be, then I think that they will be sort of like more accepting of things on the side and have not had any negative indication about it. And if they ever did have a problem, then, for example, things like Google Inbox and other apps would be at risk, and that would be a much more political thing to happen. And so I don't see that being an issue, but as it stands right now, it is compatible with the terms of service. Yeah. All right. Okay. Well, thanks very much, everyone, and thanks for hosting as well.